Hello everyone, how are you students? I hope that all of you are doing good. So here we are once again with the AIT 5 NEET question paper discussion at physics portion. The same format we follow, we will start with some question that was already that might be trouble you, and after that we will be discussing them on a detailed basis and see the concept behind them, whatever the concept that we require. Okay, so let's just start with the questions one by one. So here's the first question. The dimension of d2f upon dv square, where f and v are force and velocity respectively. So here, this is a kind of tricky question. Okay, you need to find out what is d2f over dv square, and you know with that which physical quantity it represents, and then you have to find out the dimension of this particular quantity. Okay, now we know that dv by dt represents what? Acceleration. And d2v by dt square represents dA by dt. Now, each time you differentiate these quantities, it means per unit time. Each time you differentiate some quantity, the dimension of time will come over it. So, we can write d2f upon dv square as d2f by dt square upon dv square by dt. Okay. This is the format that we can write this particular quantity. And this remains the same, d2f over dv square. Got it? Now, the another way to do it, d2f over dv square we can derive from f is equals to ma. If you differentiate this expression with respect to velocity, then it will become m dA by dt into dA by dv. And then again, if you will differentiate, it will become d2f over dv square is equals to mass is constant. So again, differentiation of these two functions will take place. It will become d2a over dt square, dA over dv remain as it is, plus d2a over dv square multiply by dA upon dt. Now this seems a pretty complicated, so we will go according to this. Okay. Now d2f by dt square will become ml. What is the dimension of force? It is mlt minus 2. And t square means we have t square in the bottom side. So this will become mlt minus 4. But at the same time, dv square will become what? dv square will become, now what is dv? dv is lt minus 1. And dv square means 2 times of differentiation with time. So it will become lt minus 1. lt minus 3. So here if you will divide it with it, lt minus 3, so getting what? L and L will cancel out. M L0 t raised to the power minus 1. So this option is the correct one. Now move on to the next one. Kinetic energy K depends upon momentum P and mass of the body according to this expression. And what is that? K is equals to P raised to the power A, M raised to the power B. Okay. Now we know that it's very simple. If you know the expression that kinetic energy is nothing but P square upon 2M, then from here we can say it is P raised to the power 2, M raised to the power minus 1. If you just equate it with this portion, which is P raised to the power A, M raised to the power B. So power you can compare. The bases are same. We can say that A is equals to 2 and B is equals to minus. Option B is the correct. Now move on to the next one. Yeah, a balloon is rising from the ground with an acceleration of 5 meter per second square. After 10 seconds, a stone is released from it. It reaches the ground after traveling a total distance x in the air under free fall. The value of x is, now look, just imagine this situation. This is the balloon that is rising up with an acceleration of 5 meter per second square. Now after some time, this balloon reaches this height, let's say a height h above the ground. At the same time, we release a stone, but we know that the stone is in the motion because of the balloon. So stone initially have the velocity that the balloon has acquired after this time. So after 10 seconds, what is the velocity of balloon that balloon has acquired? So v is equals to u plus 8. Now v is, we have to calculate, and it start rising from the ground. So u is nothing but 0. 0 plus 5 into 10, which means we can say velocity is 50 meter per second. Okay. Now, when we release this ball will move up and then it will go down. The fact here is that gravity will make this 50 meter per second velocity of those ball 0. And after this point, it will start free falling. So we will say that what is the distance traveled by this ball when the velocity becomes 0. V square is equals to u square minus 2g h. Now here v will become 0. U is 50 meter per second for the ball. So 50 into 50, 2 into 10 into h. Now this and this will cancel out. 25. So height here will be 125 meter. 125 meter when this ball travel. After that it will start falling, free fall. Okay. Under the free fall condition. Now we have to calculate. It reaches the ground after traveling a total distance x in the air under free fall. So only under free fall condition we have to find out. Okay. Now this is 125 meter, and above the ground this balloon has risen with an h, with a height of h that we can also calculate in terms of time, which is h is equals to ut plus 1 by 2 times at square. H is what? H is, we have to calculate, and u okay. So h we can calculate as ut plus 1 by 2 at square. Now u is 0. So it will be 1 by 2 times 5 into t square is 10 square, which is 100. 2 5 are 10. 5 5 are 25. So 250. So this ball has traveled 250 with the balloon and 125 with its own speed. So it is coming out as 375 meter. So when it go up 375, obviously when it coming back, it always cover the same distance, 375. Okay. Now 375 is the correct one. Got it? Now move on to the next one. A body is thrown vertically up with a velocity u. It passes 3 points A, B, and C in its upward journey with velocity u by 2, u by 3, and u by 4 respectively. The ratio of separation between point A and B and between B and C is AB by BC. So suppose this is the ball that we have thrown from the ground, and these are 3 points A, B, and obviously C will be nearer because the velocity is decreasing. At point A, velocity is u by 2. At point B, velocity is u by 3. And at point C, velocity is u by 4. Now we have to calculate AB, the separation between A and B, and the separation between B and C. Now, A and B का separation कितना होगा? How to calculate that? So it's very simple. Just apply this formula. V square is equals to U square minus 2GH, because it is moving under the influence of gravitational force or in opposition of the gravity. So V will become U by 3 for point B. So U by 3 whole square is equals to U by 2 whole square minus 2 times G into H. So it will become U by 3 plus U by 2, U by 3 minus U by 2 equals to minus 2 times of GH. So AB we are having as, A to B we are having as, you can take the LCM here, so it will become 5U by 6 multiply by minus, and this is minus AB U by 6 divided by 2G. This minus and this minus will cancel out. So it will become 5U square upon 72G. Similarly for BC you can calculate. This will be the initial velocity, this will be the final velocity. So it will be U by 4 plus U by 3, U by 4 minus U by 3 divided by 2 into G. Again take the LCM. So it will be 12, 7U, 7U upon 12, and then here also U by 12, but minus we can cancel out with the BC. So it will be 12 into 2 into G. Okay, 12 into 12, 2 times of 12. If you take the LCM of AB by BC, AB will be 5U square upon 72G, and this will become 12 into 12 into 2 into G divided by 7. Now, just do the cancellation here. It will be U square, so U square will cancel out. Now, 12 for the 72. No. 12 6 ja. 12 6 ja 72. 6 2 ja 12. Okay. So ultimately it is coming out as 2 to the 4 5 the 20. AB by BC is 20 by 7. Now 20 by 7, option D is the correct one. A particle moves in XY plane. A particle moves in XY plane with the equation x is equals to a sine omega t and y is equals to a plus omega t. The particle will travel in which path? So for these types of question, just derive the relation between x and y. So we can say that it's very simple here. X is equals to a sine omega t and y is equals to a cos omega t. Now we know that there is an identity sine square theta plus cos square theta is equals to 1. Now similar will be true for this. We can say that sine square omega t plus cos square omega t is equals to 1. You can put down the value of sine square omega t and cos square omega t. It will be x square by a square plus y square upon y square upon a square is equals to 1. So this is nothing but the condition for this equation represents what? A circle. This is the equation of a circle having radius capital A and center at origin, which means 0, 0. So this will be having a circular path. Now move on to the next one. A particle starting from rest moves in a circle of radius r. It attains a velocity v naught. In the nth round, its angular acceleration will be its angular acceleration, which means alpha. It has been asking. Okay. Now we can simply do this analysis starting from rest, which means v is equals to u plus at we can apply. Okay. Or because the distance is mentioned here, nth round mein how much distance it will travel? In nth round, distance traveled will be n times the distance traveled in first round. Distance traveled in first round. Now, what is the distance traveled in first round? The circumference of the circle, which means n into 2 pi small r. So we can say that v square is equals to u square plus 2 times acceleration, which is tangential, multiplied by the distance traveled, which is nothing but n into 2 pi r. Now, this initial velocity is 0 and this final velocity is v naught square. So v naught square here will become 2a n 2 pi, okay, 2 pi r. Now acceleration here will become v naught square upon 4 times n pi into r. Now we know that the relation between acceleration and angular acceleration is r into alpha. Okay. Now put down the value here. So acceleration is v naught square upon 4 pi n r is equals to r alpha. So alpha will become v naught square upon 4 pi n r square. This is the correct answer. So v naught square upon 4 pi n square, option C is the correct one. Now, an object is thrown towards the tower, which is at horizontal distance of 50 meter with an initial velocity of 10 meter per second and making an angle 30 degree with the horizontal. Okay, so this is the tower here, let's see. And we have thrown an object from 30-degree angle with the horizontal with an initial speed of 10 meter per second. Now it hits the tower at some height. Let's say at this time the height is h, and the distance between tower and the point of throw is 50 meter. Okay, the object hits the tower at certain height, and the height from the bottom of the tower where the object hits the tower is. So we have to find out h. We already know what is the horizontal distance up to this height, which is 50 meter. So we can say that r, which is 50 meter, is equals to u of x into t, so that we can get the time. Okay, in what time this ball hit this height of that tower. So 50 ux will be u cos 30, which is 10 into root 3 upon 2 into time. So this will be 5, this will 10. So we can say time taken by the ball to hit the tower at some specific height is 10 by root 3 second. Now what is the vertical height? So for that we can apply this formula. Sy is equals to uyt plus 1 by 2 times ayt square. Now we know that acceleration of gravity acting in the opposite direction, so it will be minus. So Sy is equals to uy. Uy will be 10 sine 30, which is 10 by 2, which is 5. 5 into 10 by root 3 time minus 1 by 2 times 10 into 100 upon 3. So this will also become 5. So this expression will become 500 by 3. Now if you take 50 upon root 3 common, it will become 1 minus 10 upon root 3 meter. So option A is the correct one. Okay, this is the vertical height that is being hit with the stone. Okay, when we have thrown it. Now this one, an aircraft execute a horizontal loop at a speed of 720 km per hour with its wings banked at 15 degree. Now what is the radius of the loop? Now we know that this is nothing but the banked angle situation. Okay, and for that we know v square is equals to rg tan theta. Now we want to know what is r. So tan theta would be v square upon rg. Now v is given to you 720 into 720 divided by theta is also given to you. So you will say that this is nothing but r is nothing but g tan theta. Now g is 10 and tan theta ki value is given to you. Sin 15 is root 3 minus 1 upon 2 root 2. And sin theta represents what? It is root 3 minus 1 upon 2 root 2. It is the perpendicular upon hypotenuse. We know that hypotenuse square, which is 2 root 2 square, becomes 8 is equals to root 3 minus 1 whole square plus base square. So it is 8 root 3 minus 1 will become 3 plus 1 minus 2 root 3 plus base square. So this will become 3 plus 1 is 4, 8 minus 4 is 4 plus 2 root 3, which is b square. Okay, now so 10 15 from this equation will become 10 15 from this equation will become what? Perpendicular, which is root 3 minus 1 divided by base square, which is 4 plus 2 root 3. 4 plus 2 root 3 whole square. Now when you solve this equation, you will get the radius of this loop. Got it? So now let's just move to the next question. Okay, the same question we have now. A mass of mkg moving with a speed of 1.5 meter per second on a horizontal smooth surface collide with a nearly weightless spring of force constant k is equals to 50 Newton per meter. If the maximum compression of the spring is 0.15 meter, the value of mass m is. Okay. Now, give me a moment, guys. So here, the given situation is that this ball is moving with a velocity of 1.5 meter per second. It compresses the spring then. The spring got compressed and the distance traveled by the spring is, let's say, x. So there will be a potential energy stored in the spring, which is given by 1 by 2 kx square. So we can apply the conservation of mechanical energy here. So kinetic plus potential initial is equals to kinetic plus potential final. Now initial kinetic energy is only acquired by the ball. So 1 by 2 times mv square plus initial potential energy of the spring is 0 and the ball is also 0. Final kinetic energy of the ball will become 0 because when the spring compressed maximum, the ball will come into rest. And final will be 1 by 2 kx square. Now just put down the values here. mv square will become kx square. M we need to find out. V will be 1.5 into 1.5. K is 50 and x square will be 0.15 whole square. When you solve this equation, it will coming out as mass is nothing but 0.5 kilogram. So option A is the correct one. Now, a stone of mass, a stone of mass 10 kg is lying at the bed of a large lake 10-meter deep. If the relative density of the stone is 2, the amount of work done by external force to bring slowly it at the surface of the lake. So let's say this is the lake. This is the lake that we are having, and here is the stone that we have put. The height or the depth of the lake is 10 meter from the surface. Now we know that a buoyant force is acting on this, but since this relative density is greater than 1, so it is synced. Now we know that this buoyant force and the force acting in the downward direction, which is gravitational force mg, this buoyant force will decrease the net effect of this weight force. And if you calculate FB, it is nothing but density of the liquid multiplied by volume of the solid submerged multiplied by gravity. And if you see what is the force of gravity, it is rho, which is density of the solid multiplied by volume of the solid multiplied by g. Now, the apparent weight or the apparent force will be FB minus FG. FG minus FB. Okay. So, if you will see, if you will focus here, we can say that relative density is nothing but density of the material, density of the liquid, and this is given as 2. So density of the material will become 2 times density of the liquid. So density of solid is nothing but the density of material here. So density of solid के place पर you will put this. So it will become 2 times of rho LVG, and this is nothing but 2 times of FP, which means net force that you are having here is mg by 2, which is half of the FP. So this much amount of force you need to apply to lift this particle or lift this stone without acceleration. Okay. So force into displacement is the work done. So work done will be mg h upon 2. Got it? Now m is also given to you, h is also given to you, and g is, you have to consider 9.8 here. When you solve it down, the answer will be 490 joule. Now, 3 particles are placed in XY plane. 40-gram particle is located at 3-4 meter, and 50-gram particle is positioned at -2, -6 meter. Where must a 20-gram particle be placed so that the center of mass of this 3 particle system is located at the origin? Now let's say this is X and this is Y. One of the particle is placed here, 3 at 4, and one of the particle is placed here, -2, -6. Okay, this particle weight 40 gram and this particle weight 50 gram. Now, where should we place the 20-gram particle so that the center of mass lie at this origin? Which means X center of mass and Y center of mass will be 0, 0. Now, how to calculate X center of mass? M1 X1, M2 X2 plus M3 X3 upon M1 plus M2 plus M3. We know that X center of mass is 0. So this will become M1 X1 plus M2 X2 plus M3 X3. Now M1 is 40 gram and X1 is 3. So 40 into 3 plus M2 is 50, X2 is -2 plus M3 is small 20 gram and X3 position is X, let's say. So if you calculate X, it will become -1. Similarly, when you calculate Y center of mass, the formula will be M1Y plus M2Y2 plus M3Y3 divided by M1 plus M2 plus M3. Again, Y of center of mass is also 0. You put down these values. The Y center of mass is coming out as 7. So option D is the correct one. -17 will be the coordinate of particle of 20 gram so that the center of mass lies at the origin. Now, a homogeneous disk with a radius of 0.1 meter and mass 4 kg rotate about an axis passing through its center of mass, passing through its center and perpendicular to the plane in the influence of a tangential force. The angular velocity of the disk as a function of time is given. omega is equals to 4 plus 3t. Tangential force you need to find out. So firstly, tangential acceleration that will be required. So d omega by dt will be 3, which is nothing but alpha. So we know that tangential force is nothing but mass into tangential acceleration. Tangential acceleration ko we can write r into alpha. So m is the mass. M mass is 4 kilogram. Radius is 0.1. And alpha we have calculated 3 radian per second square. So when you do the 1.2 Newton of tangential force is applied, so the particle attaining this velocity, angular. Now this one, an object of mass m is connected to a wire of length L, radius r, and Young's modulus y. If the object is released from horizontal position of the wire, then find out the maximum increment in the length of wire. Now we know that at a particular instant, the particle mass will be acting down. If you resolve into two component, it will be mg cos theta and mg sin theta. Now we know that there is another force which is tension force acting as a centripetal force. Okay. So if you apply you want to calculate the net force according to this in this direction radial, because that is the tension force. So it will be mg cos theta plus mv square upon L. So this will be maximum when theta will be 1. This cos theta will be 1 and cos theta will be 1 when theta is 0. And we are measuring theta from here. Theta will be 0 for this position. Okay? When it is vertically downward, only in that case, there is a horizontal acceleration. The centripetal acceleration will act in this direction, mv square upon L. And that is produce the tension in this. So maximum tension, T maximum that we can have is mv square upon L plus mg, which is the weight of this object. Now, initially to this point, you can find out the what is the velocity of this object, and you will put that elongation will be f into original length upon y into a. So when you put this value of force, mv square upon L, you can easily calculate from here to here. This is, let's say, v velocity is being acquired. So initial velocity is 0, but initial potential energy is mv mgl. Final kinetic energy 1 by 2 mv square, but potential energy will be 0. M and m will cancel out. So v square will be 2g. This is v square. You put here, it will be m into 2gl divided by L, and L will cancel out. So it will become 3 mg. It will become 3 mg. So delta L will be 3 mgl upon y into a. Now a you can write pi r square. So 3 mgl upon pi r square into y. So option C is the correct one. Now work done by the gravitational force to bring a mass m from nr height of earth surface to earth surface slowly is. So earth surface से जो height given है, this is nr. Okay, and here is the particle of mass. Now we know that work we have to done against the gravitational force, because the force acting in between them is g capital M small m upon, from the radius of earth you have to measure the distance, so it will be nr plus radius of earth, let's say r. Now we have to apply the opposite force of it, because it is attracting, so we have to apply the same opposite force to it, so to bring the particle down. And we know that work done is nothing but change in kinetic energy, change is potential energy, and this work done is nothing but the uh, work done by the conservative force, so it will be minus of change in potential energy. So initially the potential energy will be g capital M small m upon nr plus minus g capital M small m upon r. Now you can take common, it will become g capital M small m upon r, and will become 1 upon n plus 1 minus 1. Now minus Just take the LCM now. It will become minus n minus 1. So it will become gn plus gm small m upon minus n upon n plus 1 into r. This minus will cancel out this. So it is coming out as, now this gmm upon r. This will be g capital M over r into small m into n upon n plus 1. Now you multiply with r and divide with r. So it will become gm upon r square. So gm upon r square is nothing but small g. So it is coming out as mgr n upon n plus 1. Okay. So option A is the correct one. Now the next one is two particles of combined mass m placed in a space of certain separation are released. Interaction between the particle is only of gravitational nature and there is no external force present. Acceleration of one particle with respect to the other when separation between them is r. Let's say this, when the separation between them is capital R, the acceleration of this particle is a1 and the acceleration of this particle is a2. Mass of this particle is m1, this particle is m2, but combinedly m1 plus m2 is capital M. Now what is the gravitational force applied by this particle to this? So a1 is the acceleration of this particle due to the influence of m2 particle. So it will be force upon mass, which is g m1 m2 upon r square. This is the force upon mass you have to take of m1 particle for a1. Similarly, for a2, it will be g m1 m2 upon r square upon m2. M2 and m2 is here cancel out. So a1 you are having g m2 upon r square, capital R square, and a2 you are having g m1 upon r square. Now we know that both the acceleration are in opposite direction, so a relative here will become a1 plus a2. So it will become g m2 upon r square plus g m1 upon r square. Take the LCM, so it will be g m1 plus m2 upon r square. M1 plus M2 will become capital M, so g capital M upon r square. This is the acceleration. Okay, so I hope you got this. If apart from this you are having any kind of doubt, you can connect to me on the regular classes. Thank you so much. Bye bye. Take care.